We're going live. We are now live. Okay, so last time we talked a little bit about the requirements, so I'm going to assume that you know those. Remember, maybe we'll review a little bit. Thank you. We'll review a few things that I want to talk about. So the margin of error. Okay. I think last time I told you the basic form of most confidence intervals is a point estimate plus or minus some sort of a margin of error. Okay? Such as x bar or p hat plus or minus. Okay? So these are your point estimates that we're going to use. There is a standard deviation confidence interval, and it actually doesn't follow this. But most of them are going to be your point estimate plus or minus some sort of a margin of error. So the margin of error is a measure of how accurate the point estimate is, and it depends on three factors. Okay? So your three factors are the level of confidence. Okay? And the thing that I want to point out here, well, actually, I'm going to say that. The second thing is your sample size. And the third thing is the standard deviation of the population. Okay? So, do you guys remember, maybe from your notes, what the formula was that I gave you last time in class?
X bar.
X bar.
Plus or minus.
Plus or minus.
Z sub. Alpha.
Alpha over 2.
Parentheses. Of
Sigma over the square root of n. Right? Okay, so this piece here is your margin of error. And as you can see, so you can think of z sub alpha over 2 as your level of confidence, n is your sample size, and sigma is your standard deviation of the population. So you can see those three things that it depends on. Okay? Now, we also talked a little bit last time, I think this is a good review, okay? If you've got a bell curve here, and let's say that this is your sampling distribution, you've got an x bar, okay? Now, if you go out 2 standard deviations, how much data should be in there? 95%, right? 95% of your data should be here, right? So the idea here is, you don't know where mu is. Hopefully mu is exactly where your where your sample mean is, but it could be lower, it could be higher. But the idea here is, if you go out 2 standard deviations, hopefully mu, you've got a 95% probability that this interval will contain that population mean. What's the probability that you're wrong? 5%. You've got 5%. So we call alpha equals your level of significance. And you can also think that as the probability you are wrong. Okay? Now, the most common alphas that we're going to use, alpha is 0.05. That's going to be your most common one. Okay? If I forget to ask you, if I say create a confidence interval and I don't give you an alpha, what are you going to assume? 0.05. The other 2 most common ones are 0.01 and 0.10. Usually you'll use 0.10 if you've got a small sample size. Okay? Anyway, but this is the most common easily, okay? So the idea is we go back to the 68, 95, 99 rule. If I've got 95% here, I've got my alpha split on both sides, right? So I've got half of my alpha over two, half of my alpha here, and I've got half of my alpha here, okay? And so that's where your alpha over 2 comes in, okay? You could be wrong on the high side or you could be wrong on the low side. We split that evenly. Does that make sense? Okay, so that's where that comes from, okay? And we know that if we go out two standard deviations, we're gonna be right 95% of the time, which I think everybody in your class, if you got a 95 on this test, would be happy.
Yes.
Yeah, be very happy, okay? So if you're right 95% of the time, you can be wrong 5% of the time. If we have time, I'm gonna do a little experiment here, and hopefully it'll be cool, okay? Now, so it depends on the standard deviation of the population, it depends on your sample size. Okay, so let's do an example, because this will, I think, help you a lot with your homework, okay? So let's say that a neighborhood, no, I won't say it's a neighborhood, a group of citizens thinks people are speeding and want more patrols. Okay? They measure 12 cars and find the mean speed is 59.62 miles per hour. If the speed limit is 55 miles per hour, is there good evidence of speeding? They learn from police that the standard deviation of the population is 8 miles per hour. Okay? So use a 90% confidence interval. Okay? All right, so this will be similar to a question that you might have on your homework. Okay? So the first thing we might want to do is we go through and figure out any important numbers. If citizens think people are speeding, want more patrols, okay? They measure 12 cars, Porter, what's 12?
Isn't that our sample size?
What letter do we use for our sample size?
Beta. Circle with the.
No, it's 10.
N, right? N for sample size, okay? It's important to get these letters right. If you can get these letters right, this formula will be super easy. And if you get the letters wrong, it's going to be very hard, okay? 12 cars, we find the mean speed is 59.62. What is 59.62, Cassidy?
Isn't it, X bar?
Is it X bar? Why is it X bar?
That's the mean of the sample.
Mean of the sample. Our sample is the 12 cars. Now let's ask ourselves a question. I didn't write this down today, but we talked about this last time in class, so if you have to check your notes, that's okay. Is 12 cars big enough?
Yes.
No, must be greater than or equal to 30.
It's supposed to be greater than or equal to 30, right? Okay, so it's not big enough, okay? We're gonna do it anyway. But yeah, if somebody complains and say, hey, look at your sample size, it's terrible. Okay? All right. Now maybe these are citizens and they have trouble getting the speed down and, they have a best volume, they can only get 12. Okay? So we're gonna deal with it. But anyway, yeah, that's a big problem. Okay? If the speed limit is 55 miles per hour, what do you think we should call 55?
Mu.
Why mu?
Because that's the speed limit.
Now, that's what the population is supposed to be doing, right? Now, the citizens don't think that's what's happening, but that's what's supposed to happen, right? So we're gonna use that as a population. Is there good evidence for speeding? They learned from the police that the standard deviation of the population is 8 miles per hour. Kara, what's 8? Are you whispering?
Signal?
Sigma, why sigma? Standard deviation of population. Yeah, we need all that information in there, okay? Now, just by the way, so I use sigma. In a future chapter, we're gonna not know the standard deviation of the population, okay? We're gonna have a slightly different formula, okay? So this is key. Knowing this allows me to use this formula. If I don't know that, I'm gonna have to use a different formula, which I will teach to you.
What if they don't give you what X bar is? I know there's a couple examples when I was going through the homework.
Oh, that's a good question. What if they don't give you X bar? What did they give you? They probably gave you the raw data. That means you get to find it yourself. Okay? Which is easy. Can you find X bar if they give you a bunch of numbers?
Yeah, they just give you 74 numbers, so
Yeah.
it's fine.
Put it in your spreadsheet. Pain on your calculator though, isn't it?
Yeah, you do on Excel. It's good.
Yeah, on Excel it's way easy. Okay? Welcome, Ally. All right, so, all right, whose turn is it? It must be, I would pick on Ally, but she just walked in, so we'll pick on Abby instead.
What?
What do we do next?
Well, according to my calculations, you're gonna wanna plug it into that formula.
We're gonna wanna plug it into this formula here.
Yeah.
Okay, good answer. Okay, good answer, good answer. I feel like down with you. All right, so now, tell me what to write down.
You are gonna write 59.62 plus or minus,
Z sub alpha over 2. That's where we don't know, okay? All right, so let me show you what we're supposed to do on here, okay? Now, in the back of your book and also on those pink sheets that I normally bring for the quiz, I'm going to pull up Excel. Okay? Okay, so we've got our normal distribution. Now, up to now, we've ignored some of these other tables here, but over here, you can see here, I've got a confidence level critical values, okay? These are the most common ones you're going to use, okay? If they're not on the chart, if I don't remember, please ask me how to find these, but these are the most common ones you're gonna be. We're doing a 90% confidence interval, so my alpha over 2 is
1.645.
1.645. Now, do you understand why it's 1.645? Understand the math
That's what
behind
that whole Z stuff,
Okay.
alpha over 2 is, that's the whole.
it? Right, so essentially what we're saying here, let me just back up just a tiny bit, okay? Is, can you see this? Okay, let's go over here, okay? I'm doing a 90% confidence interval, right? Okay, this is my X bar, right?
Mhm.
So my alpha over 2, how much do I have in each tail?
You have 5%.
I got 5% of each tail, right? Okay? How many standard deviations am I going out to get 90% according to the chart?
1.645.
1.645. We're going out 1.645 standard deviations. That's the plus, that's the minus. Okay? That's why in our formula we have a plus and a minus. Does that make sense?
Okay.
Okay, we're going out positive 1.645 standard deviations and negative 1.645 standard deviations. That's exactly why we have those. Okay? So now I find my alpha over 2. Can I get all that on there? Barely. Okay. Found my alpha over 2. What's my sigma?
8.
8 times 8 over the square root of
12.
12. Okay? So I'm going to recommend that if you can pull those numbers out, you can make plugging it into this formula really easy. Okay? Now the question is, can you plug this into your calculator properly? And also, I'm going to show you how to do it in Excel. Okay? So let me show you how to do it in Excel. And you follow along with your calculator and tell me if you get the same answer I do. Okay? So let me open up a new page here. So if you're doing this problem in Excel, you're going to need a lower, you're going to need an upper. Okay? So I've got equals 59.62. I'm going to do the minus first. 1.645 times 8 divided by the square root of 12. Okay? So on the lower side, I get 55.82. I'm going to copy this. I'm going to paste it. I'm going to change. The only difference I'm going to do is I'm going to change that minus to a plus. Okay? So the two values I get for my confidence interval here are, well, I guess you can still kind of see that. 55.82, comma, what was the other number? 63.41 miles per hour, okay? Now, whenever you're doing the confidence interval, I would like you to always put the low number first and then the high number, okay? And then I want you to come up with a confidence statement. Okay, and here's the statement. Whether I ask for it or not, you should always remember to do this, okay? I'm going to give you a generic statement and then you have to fill in the blanks. We are blank % confident that whatever we're measuring, the speed limit of cars is between the low number and the high number. Okay? So, Dylan, can you fill in the blanks for me based on this information here?
That's whatever, if you had one answer, we have to do those, would we have to like add or subtract them or something, subtract the high from the low?
90%.
No, so we're trying to tell you, y'all are going to tell me how fast these cars are going.
Oh, well, we are 90% confident.
We are 90% confident that,
55.8,
no, what are we measuring?
the speed of the cars.
The speed of, is it just the 12 cars?
Yeah.
No,
Well, that's
the speed of all cars. Okay, we're using the 12 to tell us what's happening with the population. We're assuming that these 12 cars are representative of the population. So don't say just the 12 cars. The 12 cars are going 59.62, we know that. We don't have any question about that. The question is, how fast are all cars going? So we're 90% confident that the speed of all cars is between
55.82 and 62.
55.82 and 63.41 miles per hour. Okay, now going back to this question, if the speed limit is 55 miles per hour, is there good evidence of speeding?
Yes,
Yes, because
we're 90% confident that they're going above that.
yes, 55 is not in this interval. Okay, does that make sense? Okay, Now, could you also tell me what is the margin of error?
I don't know. I mean, I know where it is, like in the formula right there, but I don't know which answer to
Okay.
give.
If we go back to this here, let's see if I can- what I'm doing here. Okay, so here,
Would it
let's
just be
go,
like 1.6?
let's go over to here. This is the better one, okay? So we went out 1.645 standard deviations. What is the mean speed of the 12 cars?
59.62.
59.62. I'm gonna skip that here. What's the lower end?
55.82.
55.8, and the higher end, 63.4. Okay? The difference between here and here, or you could do it from here to here because those are the same distance, right?
Mm-hmm.
What's the difference between 59.6 and 55.8?
3.8.
3.8 miles per hour. So 3.8 miles per hour is your margin of error. Okay?
Could you find it by just doing 1.645 times 8 over square root of 12?
Yeah, you could have also figured it out this way. So 1.645 times 8 over the square root of 12. That should also give you whatever we just said, 3.8 miles per hour. Because that is your margin of error right there. That's the other way to figure it out. Probably the more accurate way to figure it out. Okay? Does that make sense? All right, now let's go back to here for just a minute. Okay? And I wish we were talking about polling for a second here, but let's say, okay, we're only 90% confident. What if I wanted to be more confident? What if I wanted to be 99% confident? What would happen to your margin of error? Would your margin of error get larger or smaller?
Yeah, larger.
Get larger? Who says larger? 1, 2, 3. Who says smaller? 1, 2. Okay. All right. So even though this is the poll, we're going to pretend this. Did you guys hear yesterday on Fox News that 51% of Americans support impeachment and removal for President Trump? Okay. So usually they don't tell you what the margin of error is, and they don't tell you what your level of confidence is. Okay. I don't know. It's probably 95% because that's usually what everybody does. Okay. So let's say that they're 95% confident that it's 51% of Americans support it. Okay. Let's say that your margin of error is plus or minus, let's just say 5%. So the first question is, okay, if these numbers are accurate, and let's assume they are for the sake of this, okay? Can we safely conclude that a majority of Americans want Donald Trump impeached?
No.
Who says yes? Who says no? Okay, why not?
Well, because if you take 51% and you subtract 5,
Yeah,
you're
could
below
be.
50%.
it could be as low as 46%, right?
Yeah.
Or it could be as high as
56%.
56%, okay? So we cannot say safely that a majority support impeachment. It could be as low as 46%, okay? Now, my next question is, what if I wanted to become more confident? I don't like 95%, I want to be 99 or 100% confident, okay? Now, what I could say, let's say that I want to be sure that I'm right, okay? I'm 100% confident that the percent of people who support impeachment is between 0 and 100%. Prove me wrong. Okay, what did I just do with the margin of error?
Within the other percentage.
Yeah, I made my margin of error as big as possible, right? Plus or minus 50%, right? Okay. So if you want to be more confident, just make your margin of error bigger. Okay? And so if you want, so higher confidence leads to higher margin of error. Okay? If you want higher confidence, you're going to have to make your margin of error bigger, because what's going to happen is, looking here, if I go 95%, if I wanted to go 99%, okay? Well, if I want to be 99%, I'm going to have to go out and say 3 sigma, right? Negative 3 sigma, positive 3 sigma. I just made that area bigger. Does that make sense? Okay? And, okay, so when I increase your confidence, you're going to increase your margin of error.
Are you wanting a large or small margin of error, or does it matter?
Well, generally, these things play against each other, right? Okay? What if you wanted a smaller margin of error? Okay. What could you do? What if you want to keep your confidence level the same, but you want a smaller margin of error?
You're gonna larger sample.
You're going to get a larger sample. If I get a bigger sample, what's going to happen to this overall fraction? They put a big number in the denominator. It's going to make that a smaller number overall, correct? So as your sample size, I'll abbreviate that as SS, increases, your margin of error decreases. Okay? So let me show you a quick example here. If I go back over to my spreadsheet, okay? If I change this, instead of 12 cars, we're going to do 120 cars, okay? Remember, the first time the answer was 55.8. Now it's 58, okay? And I changed this 12 to 120, okay? Now it's 60, okay? Look at my margin of error. What's my margin of error in this case? Roughly 2. Well, it's 2 divided by 2, so it's actually 1, right? About 1 mile per hour, okay? So more cars. Is there stronger evidence now that I've got 120 cars instead of 12 cars? There's stronger evidence of speeding, right? They're going at least 3.5 to 5.5 miles per hour over the speed limit, right? Okay? All right, so so that's how that works. And then, of course, the standard deviation of the population. These are kind of related, but yeah, if I have a smaller standard deviation, I can't really, that's not something I can really change though, right? But that's going to make your margin of error smaller as well. Okay? All right, now I do want to show you, do you guys feel comfortable that you can do some of the homework problems now?
I just have one question really quick.
Okay.
So the Z alpha over 2 part, so I know we go to the table to find that,
Yeah.
the numbers, but where does the divided by 2 come in?
Okay, so that's what I mentioned at the beginning. If you're 95% confident, let me make it short here. One video here. If you're 95% confident, how unconfident are you?
5%.
You're 5%, okay? We go out 2 standard deviations, what's in the tails?
2.5%.
2.5%. So I'm going to take my level of significance, which is alpha, and I'm going to put half of it on this side and half of it on that side.
Okay.
So your level of significance, I wrote that right here. Probability that you're wrong, there's a 2.5% probability that you're wrong on the high side, and there's a 2.5% probability you're wrong on the low side.
Okay. But when you get that number from the table, you're not like dividing it all, you're just putting the number straight from the
No, you
table.
can pull the number straight off the table. But that does bring up another question, okay? What if I want a 75% confidence interval? That's not on my table, right? It's not on my small table. It is on my big table. Okay, so let's think about that for just a moment, okay? Let's say that, what can I erase? We'll go over there, we're gonna erase this. Okay, let's say that I want a 75% confidence interval, okay? I want 75% of my data to be here. What's my alpha over 2? Or what's my alpha, first of all?
Wouldn't it be 25 over 2?
Yeah, so your alpha would be 25%, your alpha over 2 would be half of that, 25 divided by 2, which is 12.5%, right? Yep. So that means I've got half of my alpha here, 12.5%. I've got half of my alpha over here, which is 12.5%. Okay? Now, that's not on my chart. It sucks, right? Okay, so here's how you would find a 75% confidence interval. Let's go back over to here. Okay. Okay, so remember, these are your p-values. Okay, I want 12.5% in one of my tails. So what I'm going to look for in here is about 12.5%. That's 9, 10, 12. Oh, look at that. That's pretty doggone close. What is the z-score associated with that number?
-1.
Negative 1.15. Okay? So in this case, going back to my picture here. Okay? Negative 1.15 gives me 12.5% to the left. What gives me 12.5% to the right? 1.15. 1.15. How did you come up with that?
Just because we know whenever we
Because
have
it's symmetric.
on one side,
Yeah, it's symmetric. That's exactly right. That's why we love symmetry. Now, by the way, in a few weeks, we're going to do a distribution that is not symmetric, and you'll be sad. Because you can't do that. But it's really nice to have symmetry, right? Okay? But that's where the plus and your minus comes. So if you get the negative, just use the positive. Okay? Does that make sense? All right. Do you feel like you can do one of these problems? Okay. I don't know if I should do another problem or if I want to show you a demonstration. I kind of want to show you the demonstration. Do you guys remember when we did the demonstration of the IQ scores? Okay, I want to do that again, and I want to show you why. Okay? So here's what I'm going to do. I'm going to pick random, and I'm going to do this kind of fast because we've only got 10 minutes left. I don't want to do, so 75 and 125. I kind of want to do another problem if we have time. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to go down 100 rows. We're going to copy this. We're going to say special values. Okay, insert. I'm going to find the population mean. So the population mean is equals average of everything here. Population mean works out to be 99.9. Okay. Now remember, my sample size is supposed to be 30. This is a case where I can get by with smaller than 30. Okay, I'm going to do a sample mean. Okay, sample mean is average of each of these. Okay, so we've got 100 sample means here. Okay, now the idea behind the confidence interval says, of these 100 sample means, I'm going to find 100 confidence intervals. Okay, and I'm going to make a prediction. I think 95 of these are going to be right and 5 of them are going to be wrong. Okay, now maybe it's 4, maybe it's 6, we're going to see, but that's the idea here. Okay, so now here's what I want you to do. We need to find a lower limit, and we need to find an upper limit. Okay, and
Is this
who
what
wants
we're
to
gonna
practice?
need to be for Excel?
What?
Is this what we're gonna need to do next week?
You will need to do this in Excel. Well, not this exact problem, but if I give you data, you should be able to find a single confidence interval. I'm not going to ask you to do 100, but I'm going to do 100 right now, really quick. Okay? So, who feels confident and wants to tell me how to make this confidence interval? Abby?
Are you using that formula? We're
We're
not.
using that same formula. Equals, and we're going to do a 95% confidence interval. 95%.
So you're gonna take that
Oh, actually,
cell,
let's get my Z sub alpha over 2 before I start. Z sub alpha over 2.
you were 95, is that what you said?
95% confidence interval
So
according to my chart
1.96.
is 1.96, which is almost 2, right? So technically, you shouldn't use 2, you should use 1.96. That's why we call it the 68, 95, 99 rule. We just round it to 2. It's actually 1.96. Okay, take it away, Abby.
So you're gonna equal
Equal this
That cell.
mean, right?
minus
Minus
your Z sub alpha,
V sub alpha over 2. I'm gonna F for that one. I want it not to change.
and you're gonna multiply that.
Oh, we forgot to find out our standard deviation, didn't we?
with,
Okay, sorry, that was the one thing I forgot. So the standard deviation of the population is, how do I find that?
highlight everything. You just
Standard
scan it.
deviation of the population, and then highlight everything. Okay, now we've got all the information we need. All right, so take it away again, Abby,
So you
sorry.
go that cell, the 96,
96 minus
the
V sub alpha, I'm gonna F for that,
F for that, times it by two.
times the standard deviation, I'm gonna F for that, divided by
Your
square root, what's my sample size on that row?
10, no,
It's actually 9,
9.
okay? All right, now I'm gonna copy this thing. What's the only thing I'm gonna change? That minus is now gonna become a plus. Okay, now let me ask you a question. Population mean is 99.9, is that in my interval? It is, okay? I'm gonna copy this formula down. Now, what's hard to see is which one's not in here. So I'm gonna create this statement. You don't need to know how to do this. If this is greater than this, comma, this is less than this, and don't do anything else to put out of range. Okay, I'm only doing this to make it easy to figure out which ones are out of range. But hopefully, when I do this, this is gonna be easy to see, and there should be roughly 5 out of range, okay? Okay, look at that, 99 is not in that interval, so that one's wrong. Does that make sense? Let's see if I can get 4 more wrong ones. That one's not in the interval, that one's too high, right? 99 is not in there. That's 2. That one's too low, that's 3. That one's too high, that's 4. That one's too high, that's 5. Oh, I got 6. That was pretty close to 95% accuracy, wasn't it? Okay? So the reality is, if you repeat this 100 times, we expected to get 95 of them right, we only got 94. It's pretty darn close though, right? Okay? So the confidence interval says you're gonna be right 95 times, you're gonna be wrong about 5 times. Does that make sense?
Yeah.
Okay? We were right 94 out of 100 times. The population mean was within this interval 94 times. It was wrong 6 times. Okay? Does that make sense? Okay? Now, most people don't do 100 confidence intervals, they only do 1. And 95% of the time you're going to be right. 5% of the time you're going to be wrong. Okay? Just by chance. Okay? So we've got 3 minutes left. Do you want to do one more or do you want to go?
3 minutes.
Tough question. Up to you.
One more of what, one of those?
Do a problem.
How about you do one of those of what would be similar to what we're gonna see on our Excel test? How about that?
So on your Excel test, here is a bunch of data. Find a 99% confidence interval. If standard deviation is known to be 3.5. Equals, so here's my data. I just like to use random numbers because here's stuff 34 and 65. Okay? There's your data. First of all, is that enough data? No,
No.
how many do I need?
30.
30, let's go down, we're gonna make more data. Is that enough data?
Yes.
Okay. So copy, there's your data, okay?
Okay.
Now, according to your formula, if you want to look at your formula, what do I need? I need to know X bar, Z sub alpha over 2, sigma, and n, right? How do I find my X bar?
Average.
Equals average. What am I looking? 48.3, what's my Z sub alpha over 2? Oops, it's supposed to say 99%.
2.575.
2.575, how did you get that number?
Look at the table.
Look at the table. 2.575, what's your sigma?
3.5.
3.5, what's your n?
How do we do?
Your n is 53.
Okay.
Okay?
And then we're gonna plug that into the
Plug all those
formula
into
to
that
find your
formula.
upper.
Do you want to do it really quick? Or no, we already did one. Let's pick on Ally. We haven't picked on you all class. Lower, upper.
Okay.
I'm giving you all the numbers you need. You just gotta plug them in.
So you,
Oh, by the way, let me just mention one thing really quick. One of my students plugged this in. He used all the correct numbers, but he didn't know how to use his calculator, and he got the wrong number. So check and make sure you know how to use your calculator. Every calculator is different. If you don't know how to use your calculator, what do you do?
Look up on YouTube.
YouTube.
oh,
You know, Casio, FX 360, whatever model. How do I do this? And I'll show you. Okay? Equals
your X bar.
X bar, which is 48.3, minus
Minus your Z's of alpha.
use of alpha.
F4.
You don't need to F for it, but you could. Sometimes you will, sometimes you won't. You really don't need to do it here.
Times your sigma.
Times sigma divided by
53.
square root of 53. Not just 53, don't forget your square root, okay? Now, if you copy it here, it won't work, okay? But if you copy it up here, press Control C and paste it, what's the only thing I need to change now? Minus 2. And Kara's gonna give us a confidence statement, because I know she's confident that she can do this.
We're 99% confident.
99% confident. What'd you say? The beta test scores, we're gonna do their test scores. Test scores.
Between 47.
Between, what'd you say?
Between 47,
47.1 and
49.5.
49.5. This is out of 50 points, right? But they would be good scores if that was the case, right? Okay. All right, you gonna ace my quiz on Monday?
Oh, yeah.
Mondays when we're taking testing center, Brian?
Oh, Monday, yeah, Monday we'll do the testing center test.
And it closes on
For
Wednesday.
free, you can take it Tuesday or Wednesday, but it'll cost $4. Wednesday will be the in-class test. We will meet in our regular class in science building on Wednesday. Monday we can meet here. Okay, yes.
Are you gonna post Excel like practice questions that are gonna be on the test or you just?
No, but I'll try to come up with a review sheet for you saying, do you know how to do these things? But yeah, you want me to save this and you can look at it?
It's just gonna be on like the last few chapters, it'll be on every single chapter.
Will you post the
So
video?
here's the deal. Yeah, I'll post the video. Here's the deal. I will, what did you ask me again?
Is it gonna run every chapter or just?
Oh.
last few?
It's gonna be on chapters 5, 12, 15, and 16. However,
It's not the ones we took the last lesson.
the last 4 is what I'm gonna focus on, but those are based on that you can identify your sample and your population, so it's not like you can forget that stuff, okay? So, just don't forget the other stuff, because you need to know that to do this, okay? So, but yeah, it'll be primarily those 4 chapters, okay? So, and I'll try to post a review sheet this weekend if I remember. If not, just, text me something. And I will post this up on the website so you can look at this. Okay?
I sent you the note.
Thank you.
Yeah, so you work before class, is that okay?
Well, the computer part I don't have to worry about.
Yeah. No, just the written, so. Yeah, I'll send another one to you.